In this lesson, I'm going to go over how we use trigonometry to find missing sides. So what we saw previously is how to find the ratios, and now we're going to see how do we use those ratios to find missing side lengths in a right triangle. So we'll definitely need to identify the information that we're given. So we'll need to identify the reference angle, the hypotenuse, the opposite side, and the adjacent side. Before we get into an example, I want you just to recall, you don't have to write this down, but I do want you to recall that the reference angle in a right triangle, so remember if this is my right triangle, remember the reference angle is just one of the acute angles. So I could maybe call this one A and this one B. Another thing I wanted to mention before we get into our examples is that in Math Excel there is no calculator that has a trig functions in it. So what we need to do is you're going to need to use an online calculator for this part of your homework. So what you're going to do is you're just going to go to this link. I'm going to copy this real quick. You're going to go to this link. I put it in Google Classroom. I'm going to go to it real quick so you can see what the calculator looks like. It looks like this. This is the calculator that you're going to need to use because, like I said, Math Excel does not have a calculator that has trig functions. So I will pull this up when we do a couple of examples so you can see how this calculator gets used. So this is example 1. We're trying to find the missing side length, and we're going to use trig to do that. So if you could sketch the example, pause the video if you need to, sketch the example. In example 1, what we're going to want to do is we're given a reference angle, and now instead of calling it theta A or B, we're actually giving the reference angle an angle measure. So my reference angle in example 1 is 29 degrees. That is my reference angle that I'm given. What we're going to do first is just like before, is we're going to take and we're going to identify what our side lengths are when we look at our reference angle of 29 degrees. So let's start with the hypotenuse. So remember, the hypotenuse is across from the right angle. So 15 is my hypotenuse. Now I'll label my adjacent and my opposite. So maybe let's start with the opposite. So remember, opposite is across from your reference angle. And the adjacent, remember, that's the side that touches your reference angle. So here's adjacent. So let's go ahead and fill in what we know. So we know theta. Theta is 29 degrees. We know opposite is x. So this is, we'll label that as x. We don't know the adjacent. There's no information. We're not given a letter. We're not given a number. So we don't know that. So let's just go ahead and cross that off. We don't know what adjacent is. And then we know the hypotenuse is 15. So what we can do to find x is we can use our trig ratios. So let's go ahead and write that. Remember that that saying we have to help us remember our trig ratios is SOHCAHTOA. If I want to find the opposite side, and I'm given the opposite, I'm given theta, and I'm given the hypotenuse, what I want to know is what trig function relates my two sides that I'm given. So I'm given opposite and I'm given hypotenuse. Which trig function relates those two sides? So I'm going to look at my SOHCAHTOA. I have opposite, so I have O, and I have hypotenuse, I have H. So that means I'm working with this one, SOH, because sine relates opposite and hypotenuse. So for my setup, what I would say is I'm going to use the sine function. So I would say sine of theta. And what is the sine of theta? Well, sine of theta is opposite over hypotenuse. So I would say opposite over hypotenuse. Now let's go ahead and plug in. So where it says solve, let's go ahead and plug in our value for theta, our opposite, and our hypotenuse. So I'm going to write sine of theta is 29. So this is an angle measure, so it's 29 degrees, equals opposite is x, and hypotenuse is 15. We want to figure out what x is, so we want to figure out what our opposite is. What we'll do is we'll multiply both sides by the denominator. So we'll multiply both sides by 15. So we'll cross off the 15s. So this is 15. So we'll say this is sine of 29. In other words, don't plug that into your calculator just yet. Equals x. The sine of 29 is just a number. You could plug that into calculator and you would get a number. So what we're going to do is we're just going to multiply 15 times the sine of 29 using the calculator so we can get an exact answer. Now we'll go ahead and open the calculator. And I want to do 15, so I'm going to do 15. And this means multiply, so the 15 in front of the parentheses means multiply. So I'm going to do 15 times, so here's my multiplication. So then I want the sine of 29, so I'm going to click sine, and then I'm going to type 29, so 29, and then close the parentheses. And then this tells me that 15 times the sine of 29 is 7.27. So I'd write my answer as that side length is 7.27 equals x. So now I could tell you what's the length of my opposite side opposite my reference angle. It would be 7.27. So that's the side length of the side opposite the reference angle. Example 2. We're going to start it the same way we did example 1. So let's go ahead and write SOHCAHTOA, just so that we have it. And then I'm going to start with my reference angle. So here's my reference angle is 41 degrees. And then label your triangle. So here's my right angle. This is the hypotenuse, because it's across from the right angle symbol. I'll label my opposite. So opposite of my reference angle is this side. So opposite. And then the side touching my reference angle is this side. So this is my adjacent. So I'm going to write ADJ. So 15 is adjacent and X is the hypotenuse. So let's fill in the given information. So we know theta. Theta is 41 degrees. Opposite. I don't know anything about the side opposite. I'm not given a letter for the side opposite, and I'm not given a number. So we can cross that off since we weren't given a letter or a number for that one. So the adjacent, the side next to your reference angle, is 15. And then my hypotenuse, I don't know. So I'm going to call that x. So this is helpful. Now I know I don't have opposite, but I do have my adjacent and my hypotenuse. So I'm going to look at my trig functions. Which of those relates adjacent to hypotenuse? So if you look, that would be my cosine. So I know I'm going to do the cosine of my reference angle, so the cosine of theta equals the adjacent over the hypotenuse. And then I'm just going to plug in my values. So I'm going to say the cosine of 41 equals, what was my adjacent? It was 15 divided by x. So the best way that I could think to solve this one is to think of this as a proportion. So think of this as the cosine of 41 divided by 1 equals 15 divided by x. This will probably be the easiest way to think of solving this one. So if I want to solve this, what I would do is I would solve this proportion. So remember, when you solve a proportion, you multiply along the diagonal. So I would do x times the cosine of 41 equals, then along the second diagonal, I have 1 times 15. And now x cosine of 41 is just going to say x cosine of 41. And then 1 times 15 is just 15. but we want to get x by itself. We don't want cosine of 41 with x. So the way that we get x by itself to find our hypotenuse is we're going to divide both sides by the cosine of 41, because the cosine of 41 is just a number that the calculator is going to give you. So what's going to happen is that these are going to cancel off, and I'm going to get x equals 15 divided by the cosine of 41. So I want to point out something is I mentioned the cosine of 41, you could think of it as just a number because that's all the cosine of 41 is, it's a number. But what we want to do is we want to hold off on getting the decimal approximation of cosine of 41 because that would end up getting us an approximate answer. Whereas if we leave it as cosine of 41 until this very last step here, then when we plug it into the calculator, we're going to get an exact answer. So here, I'm going to plug in 15. I'm going to clear this. So I'm going to plug in 15 divided by the cosine. So I want cosine, and this is 41. So I want the cosine of 41. So my answer here would be 19.88. So x is 19.88. So this means my hypotenuse is 19.88. So this would be like your exact answer, and this would be an approximation. Because remember, the cosine of 41 represents a decimal. So here that green part would be an exact answer. My 19.88 would be an approximation. So here's example 3. So what I'm going to do first, I'm going to identify my theta. So my theta, or my reference angle, is this green angle. It's 63 degrees. So after I find my reference angle, let's go ahead and find the hypotenuse. So here's my right angle. Across from the right angle is the hypotenuse. I think it's best to identify your theta and then your hypotenuse. So I don't know what the hypotenuse is. So I'm just going to cross that off because we don't have any information about the hypotenuse. Now let's label the side across from 63 as my opposite. So it's a 16. And then the side that's next to 63 is x. So that's my adjacent. So if you write out your 3 trig functions, so toa, which one of those relates opposite and adjacent? So hopefully you can see that that would be the tangent. So for my setup, I would say this would be the tangent of theta equals the opposite, OPP, over ADJ. And now to solve, I'll just plug in my given information. So I'm going to plug in, I'm going to say the tangent of, well, what's theta? Theta is 63. So I'm going to write 63 equals opposite over adjacent. Well, opposite is 16 and adjacent is x. So we're going to solve this. So tangent of 63 equals 16 over x. Ooh, there's an x in the denominator. So when x is in the denominator, you're going to think of this as a proportion. So you're going to think of this as tangent of 63 divided by 1 equals 16 divided by x. Think of it as a proportion. So now you're going to cross multiply. 1 times 16 equals, then do the other one, x times tangent of 63. So this is just going to be 16 equals x times the tangent of 63. And remember, we're just going to leave this as tangent of 63. We're not going to approximate it here because we're going to approximate at the very end. So what we'll do is we want to get x by itself. So since tangent of 63 is really just going to be a number, we can divide both sides by the tangent of 63. So those cancel off. And I get 16 over tangent of 63 equals x. So this is the side, this is what the measure of my adjacent side is. So I'm going to open my calculator. I'm going to clear it. And now 16, I'm going to do 16 divided by tangent 63. So I'm going to use the tangent I want to write 63. And so this is 8.15 would be my answer here. So the length of x is 8.15. So that is the length of my adjacent side, is 8.15. So, and then I just want to show you that I've been telling you that these trig functions, it represents a number. Like I told you that tangent of 63 is a number. So I just want to show you that it is a number in the calculator here. So if I type tangent of 63, I get 1.96. So one thing I want to point out is that when we found missing measures, there was sort of two cases that we could have come up with. And you don't need to write this down, but I do want you to be aware of it. So we came up with two cases, sort of. Case one was when we saw, this was like example one. So what we saw with example one is you could solve and you could have x in the numerator. And if x is in the numerator, like then you just multiply both sides by the denominator. And that was a pretty straightforward one to do. You just multiply, just put the multiplication in your calculator. The second case that we came up with, and this was sort of the one usually is a little bit more challenging, is when you're dividing by the letter. And we saw this in examples 2 and 3. So if you come across something like case 2, like we had in examples 2 and 3, you're going to think, remember I said, think of it as a proportion. So they didn't show it here, but your proportion would be this divided by 1, and then you'd cross multiply. So think of it as a proportion. And then you can go about solving it that way. So you should be able to finish that Math Excel assignment that you started the other day, trig ratios and finding side lengths.